Bismillahirrahmanirrahim. Today in this lecture, we are going to speak about the real number system. Starting with the number sets. We have different type of different sets for the numbers, starting with the smallest one, which is the natural number. We call this list starting with 1, 2, 3, 4, 5, 6, 7, up to infinity is or the natural number set, or we call them natural numbers. So the name of this set starting with 1, not 0. Start from 1, the smallest number is 1. Then 2, 3, 4 is called the natural number. Also, we have another set called the integers. Integers are negative numbers. It is -3, -2, -1, 0, 1, 2, 3, 4, up to plus infinity. This will go to plus infinity because it's a plus infinity, or from the left up to minus infinity. These are integers. Integers mean we don't have fractions or part of the number. We don't have 0.5 or 1.5. It is just an integers, or that's just our integers. So the numbers -1, or sometimes we can write it in the line numbers 0. Then the positive to the right is +1, +2, +3, up to plus infinity. To the left, we have negative numbers, -1, -2, -3. So we don't have something -1.5. We don't have these fractions. So what we have, integers. Negative numbers, positive numbers, plus the 0, because these are integers. We have also another set called the rational numbers. It is all terminating or repeating decimals. Or sometimes we can say it is any number can be written as A over B. So rational numbers, it is the numbers that can be written in this form, A over B. Numerator, the up, we call numerator, the down, we call the denominator, where B is not equal to 0. A and B are any integer numbers. A and B are any integer numbers, but with one condition, that B is not equal to 0. So any number can be written in this form. We call it rational number. The next one are the irrational numbers, or non-terminating or non-repeating decimals. So any number cannot be written in this form, A over B. We call it irrational numbers. And the irrational numbers, for example, we have square root of 2 is irrational number. Square root of 3 is irrational number. We have something called pi, which is approximately equal to 3.14 with more decimals. Also, this is irrational numbers. So square root of 2, square root of 5, or square root of 3, or the number that doesn't or don't have integer square root, or they are not perfect square. Sometimes it is the 3 or 2, it is not equal to something to power 2. So square root of 2, square root of 3, square root of 5, square root of 7, all of these are irrational numbers. So if we combine all of these together, we have what's called the real numbers. So the real numbers are all rational or irrational numbers. So it contains all these sets: natural, integer, rational, and irrational. Or we can simply say that R, sometimes we just using this notation for the real numbers, is equal to the rational, this is the Q. We are using this notation for the rational numbers. Union means we are adding this symbol, means union. or it is or. And this is the I, irrational number. So the real numbers are the rationals or irrational, or rationals or irrational and irrational numbers, because this is the real numbers. Sometimes we need also to define the number or to classify the numbers into or in different categories, different types. So we have something called the prime number, and we have composite number. Prime number is any number that can be written as multiplication of two numbers, only one and itself. For example, 2 is 1 times 2. 3 is 1 times 3. We don't have other divisors. So we can say a prime number is a positive integer. A positive integer, it is positive number, greater than 1, that has no positive integer factors, or we can say divisors. It can't be divided by any other number other than 1 and itself. So these are, for example, 2, 3, 5, 7, 11, 13, 17, 23. All of these are prime numbers. I cannot write this number as multiplication of two numbers other than 1 and itself. So it is 1 times 2, 1 times 3, 1 times 5, 1 times 7. So we call these are prime numbers. The second one is the composite number. For example, the number 4. So it's composite. It can be written as 1 times 4. It can be 2 times 2. So the composite number is a positive integer greater than 1 that is not a prime number. If it is not a prime number, then we call it composite numbers. For example, number 10, we can say it is 1 times 10, or we can say it is 2 times 5. So since it has more than 2 factors, other than 1 and itself, it has another factors or divisors, then we call it composite number. Now for the real numbers, start with these exercises. I need to determine whether each number is an integer or a rational, prime, or a real number. Let's start with the integer number. We are using for the integer z. We are using this notation for the integer number, and also the rational q and irrational I, and also we have prime number or real. Set up with the real number first. R and prime. Let's see the number 1. Minus 1 over 5. Is it integer number? No, it is not. 1 over 5 is not integer. So the first one is minus 1 over 5. This is rational number. 0 is integer and rational at the same time. Minus 44, it is integer and also it is rational. By the way, all the integer numbers are rational numbers. All the integer numbers are rational numbers. Pi is irrational. 3.14. 3.14, we go back to see the definition. Rational or terminating or repeating decimal. Terminating means we can find the end of the decimal number. We call this is a decimal. After the point are decimal. Since we have only 2 digits, 3.14, and that's it. So this is rational. Now 5.050050005000. This is not terminating decimal. I start with 05, then 005. It is not repeating the same number of digits. 0005, then 00005. So this is not terminating decimal. So this is irrational. So we can say 5.05, 005, 0005. This is irrational number. Next one, 81. We know that the square root of 81 is 9. 9 is an integer, so square root of 81 is integer, and also at the same time it is rational. 53 is integer and rational. Now what about the real numbers? Real number will contain all of these numbers. All of these are real numbers now. So we can say it is -1/5, it is 0, -44, it is by 3.14, 5.05, 005, 005, and also the square root of 81 and 53. Because we define the real numbers are the rational and irrational. So all of these are real numbers. What about the prime numbers? Let's find the prime numbers. Let's go back to see the definition. We said that prime number is a positive integer. First of all, it must be integer number. It is an integer number greater than 1 that has no positive integer factors. So we see that these numbers, first of all, it is integer number. So we are looking for this set. We'll take the prime number. This is 0. Is it a prime number? No, because we say that the prime number must be greater than 1. Greater than 1. So 0 is not greater than 1. It is not a prime number. So this is not a prime number. -44, it is not because it is not positive. 81 equal to 9, but we know that 9 is 1 times 9, or it is 3 times 3. So it has 3 factors, or it has factors other than 1 and itself. We say prime number, it is the number that can be written as just 1 multiplied by itself. So the only remaining one is 53. So prime number will be 53. So these are the sets and the classification of the real numbers. We have natural numbers, we have integer, we have rational numbers, we have irrational numbers, and we have real numbers. Also, we have prime numbers and positive or composite numbers. Sometimes we can classify the numbers as prime numbers or positive or composite numbers. In the coming part, we are going to speak also about how to write the set using the set builder notation and different type of writing the sets. What we have now up to now for this number, if we write it in this form, 1, 2, 3, 4, this form, we say we list all the elements or members of the set. We have different notations or different ways of writing the set that will be discussed in the coming part.